Hello, good morning everyone. I am your science teacher. Now to everybody knows. Okay. So today we will do the last part of this chapter 14, electric current and its effects. Before starting the explanation, I want to give some instructions. You have to listen the explanation carefully and read the chapter 14, electric current and its effects, page number 167 to 169. And after that, see the given PDF and copy exercise from PDF in your notebook. In my previous explanation, I have explained about the heating effect of electricity. Today I am going to explain magnetic effect of electric current. For this we will do the activity. Take a cardboard tray from inside a discarded matchbox. Understood? जो मैच बॉक्स अपना टूट जाता है या ख़त्म हो जाता है उसके अंदर का जो कार्डबोर्ड होता है वो हमको लेना है एंड देन रैप एन इलेक्ट्रिक वायर अ फ्यू टाइम्स around the cardboard. Around the cardboard we have to wrap that electric wire and place a small compass needle inside it. Compass needle everybody know? It shows the direction north south, always it indicates. So now connect the free end of this wire to an electric cell through a switch as shown is figure. Like this we have to make circuit, and then we will note the direction in which the compass needle is pointing, and then we will bring a bar magnet near the compass needle, and then we will see what will be there. We will see that watching the compass needle carefully, we will switch on the position, and when we will switch on the position, then what will start? That current will start flowing in that. Okay, and then we will observe the needle, and again we will switch off, that current will stop passing, and then again we will see the position of compass needle. We know that the needle of a compass is a tiny magnet which points in north-south direction always. When we bring a magnet close to it, the needle gets deflected. And we have also seen that compass needle gets deflected when the current flows in a nearby wire. Okay. And who has first observed this? This is what that one scientist called Hans Christian Ørsted also wondered to see that. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. Okay, so when electric current passes through a wire, it behaves like a magnet. If we will bring any iron thing near that, so it will attract that iron thing, so we can prove that it will behave like a magnet. This is only the magnetic effect of electric current. Now we will see that an electromagnet. What is electromagnet? To see that, again we will do one activity. We will take around 75 centimeter long piece of insulated wire. Insulated wire means it is wrapped with a plastic or cloth cover. That is insulated wire, which you have seen that at home also. In mobile charger also you can see that wire, that is insulated wire. It is coated with the plastic. Okay, so many in all appliances you can see that wires are used, that is insulated wire only. That wire we will wrap on nail, one flexible iron nail. That flexible wire we will wrap on iron nail, and then connect the free ends of the wire to the terminals of a cell through a switch as shown in figure. You can see in this figure. Okay, and when we will see that in figure, that wire is coiled, wrapped on this nail. Okay, and near the nail down if we will keep some pins and then switch on the current, then current will flow. So we will see that pins will attract to the nail. Why it will attract to the nail? Because it will behave like a magnet. Okay, and when we will stop that flowing current, switch off, then what will be there? Then coil generally loses its magnetism. Such coils are called electromagnets. Now understood what is electromagnet? Okay, same process is working in our electric bell. Electric bells everybody knows, at home, outside, all are having. In this pic it is given that circuit of an electric bell. Inside what is there in electric bell, that I will explain you. In figure you can see that it consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with the hammer, like hammer you can see, okay, that is at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. Okay, it then pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong. Gong, what is gong? That round is given in bell. Okay, structure round is given and that is made of metal. Okay, that is gong. Then strip ring on that, okay, of the bell to produce a sound, and then it produce the sound. तभी हमको सुनाई देता है, हमारी बेल बजती है, कोई भी आता है, जब उसका सर्किट कंप्लीट होता है, स्विच ऑन होता है तो. However, when the electromagnet pulls the iron strip, it also break the circuit. Okay, when we stop that, touch that bell switch, so electromagnet pulls the iron strip and it also break the circuit. So our sound is stop coming. Okay, the coil is no longer an electromagnet that time. The iron strip comes back into its original position and touches the contact screw again. Okay, so again and again if we will switch on, that bell will ring. So how you understood now this, how the bell rings? Hope you understood the explanation. Okay, you have to listen it again if you can't understand, and read thoroughly the chapter 14, page number 167 to 169. This is the last part of this chapter. Okay, and see the PDF and do the exercise given in PDF and mail it to the given mail ID. Okay, this time I want all should send the mail because I am getting very less mail. Okay, and you know that your internal marks you will get on the basis of these mail only, because through mail only we can get your homework or classwork. Is it clear? So everybody have to send mail to me.